Okay, so last section we're going to take a look at is 10.1, and that's on solving systems. Remember what a system is. Okay, a system is when you're solving for multiple variables, okay, a minimum of 2. In general, the kind of problems that I give you, if you have to solve for 2 variables, the way it'll be set up is I will give you 2 equations. If you have to solve for 3 variables, like in this one, I will give you 3 equations. So you're always going to have as many equations to solve as there are variables. And there's different ways to solve using elimination and substitution are the 2 main methods. We'll talk about both. So this one, I just want to set it up. We're going to solve it in the next step. Okay, there will be a word problem type question on the test. So you have to know how to translate something in words to write it. Okay, we can do another one after, but let's start with this one. So it says the length and the width of a rectangle is what we're trying to find. And they give me 2 facts about the rectangle. The perimeter is 100, and the area is 300. So we're going to set up a system of equations. How many variables are we solving for in this problem? Sarah? 2. What are they? Length and the width. What would be good letters to pick to represent those? I would use L and W. I mean, some people might use X and Y if you were going to think about graphing it on a calculator. But let's use L and W for now. So L will be the length, W will be the width. How could I set up a formula that represents this piece of information? What would be an equation that represents the area coming out to 300? Okay, what shape are we dealing with?
Rectangle.
Rectangle. What's the formula for the area of a rectangle? Yeah? Length times width. So area equals length times width. How are we going to represent the area in this equation? Yeah?
Plug in 300.
Then plug in 300. We know the area. So the area equals, how are we representing length? Yep, L. And how are we representing width? W. So there is equation number 1. And if that's all you knew, there's an infinite amount of answers to that problem. Something times something gives me 300. Okay, 10 times 30. 300 times 1. 150 times 2. There's lots of answers. But they give me another piece of information. Perimeter. What's the formula for the perimeter of a rectangle?
This could be wrong. Is it 2 length or plus 2 width?
2L, yeah, 2L, 2 of the, we can write it that way first. 2 of the lengths plus 2 widths. L, L, W, W, and then add them all up. All right. Chris, how are we representing P in this case?
100.
100. We know the perimeter is 100. Equals 2. We just said length is L. And width is W. So here is the other equation that we would use to solve this problem. Here's the formula for your area. There's the formula for your length. And all we had to do was set it up. We don't have to solve it right now. Okay. Any questions on setting up those two equations? And we'll practice solving it with x's and y's too, because sometimes x and y comes up a lot when you're solving systems. So we'll practice those variables in a few minutes. So the main ways we're going to look at solving systems are using substitution and elimination. Okay, we're going to start with substitution. So in order to use substitution, the main idea is you take one of your equations and you isolate a variable. You get a variable by itself. Which variable you want to get by itself doesn't matter. Pick whichever one is easier. So pick an equation, preferably the easier one, and then pick a variable to get by itself. Once you do that, you're going to take what you did in the first step and you're going to plug it into your second equation. Once you plug that in and simplify, at this point, you're going to know one of your two answers. Okay, after step 2, you should now know like length equals 10 or something like that. Okay, but you should know the length. Once you find one of the letters, like say we got length, you plug that back into one of the formulas and then you solve for width. So you take the answer that you found in step 2, plug it into one of the original equations, and solve for the other variable. Now you can do substitution with 3 variables. We're going to try to use a little bit better method. When we get to 3, we're going to stick with elimination. But with 2 variables, I'll show you both, substitution and elimination. So we're gonna solve that problem about the rectangle. That's the one we're gonna do. I changed it to x and y's, but it's basically the same problem you just had. 2y plus 2x equals 100, that was your perimeter equation. And x times y equals 300, that's your area equation. Which one of these equations do you think it would be easier to get a variable by itself? The top or the bottom? Sarah?
Bottom. Okay,
so let's work with the bottom. And what variable do you want to get by itself? X or y?
Y.
Okay, we're going to get y by itself in the bottom. Can you tell me what you do on both sides?
Subtract the x, or divide by the x.
Divide by x. So if you divide each side by x, you get, I'll just rewrite it. You get y equals 300 divided by x. So now you have a formula for y. What am I going to do with this 300 divided by x now? Chris?
Put it into y from the first equation.
Plug it in for y in the first equation. And the goal when we do that is we're only going to have one variable left because we did a substitution. So let's see what happens. We've got 2 times change y to 300 over x. So there's 2 times y plus 2x equals 100. All right, and let's solve it. Abigail, what could I do to start solving that?
Could you multiply the x?
Multiply what?
The x?
What do you mean? Explain more.
Like we do 2 times 300 first.
Okay, let's do that. So that gives me 600. And then what were you saying about the x?
Like times, I'm not sure.
Anyone have a thought what we're gonna do? It is something with x, yeah?
Multiply each side by x.
Yeah, multiply everything by x, because what that's gonna do is it's gonna get rid of this fraction. We don't want fractions. So we're gonna do times x, times x, times x. When you do it on the left, these x's cancel. So now you have 600 plus, Jack, what's 2x times x?
2x squared.
2x squared equals, and Casey, 100 times x? 100x. What type of equation is that? We spent a chapter on those in the beginning of the year. Yeah?
It's a quadratic.
That's a quadratic. How do we generally solve a quadratic? What's the goal? I mean, the goal is to get x by itself, but what's the first step to do that? Yeah?
Factor.
You can factor it, but to even get it ready to be factorable, what do you have to do? Yeah?
Set it equal to 0.
You have to set it equal to 0. So let's get this equal to 0. And if it's factorable, we can try. If it's not, we're going to have to do something else. So I'm going to put everything on the left. 2x squared minus 100x plus 600 equals 0. Now, there's something you can do here before you even try to factor it. Does anyone see what we could do that would maybe make the factoring easier if it's factorable? Bailey?
Divide everything by 2.
Yeah, we can divide everything by 2. I mean, it doesn't make it that much smaller, but it makes it a little smaller. So x squared minus 50x plus 300 equals 0. Okay, now, if we're going to try to factor that, we need 2 numbers that multiply to give me 300, and they need to add or subtract to give me 50. Can anybody think of 2 numbers that multiply to give me 300 and add or subtract to give me 50? So if we can't think of what the 2 numbers are, it might be because it's not factorable. If it's not factorable, what's the other way we can solve a quadratic equation? Yep.
Quadratic formula.
Let's try the quadratic formula. If we get a nice answer, then we know we missed the factoring. We could have done it that way. But let's try quadratic formula. Right. Francesco, what's A? What is it? Why?
I'm just guessing.
How do we know what a is? Like, what do you look for? Tyler?
It's EX squared.
It's the number in front of the x
The
squared.
highest power.
Yeah, yeah, the number in front of the highest power in a quadratic. Yeah. So in this case, it's 1. How about b? Yeah.
Negative 50.
That's always the number that's in front of the x. And c? Yeah. 300. Good. Now let's fill in the quadratic formula and see what we get. So negative b plus or minus the square root of b squared minus 4 times a times c. So 1 times 300. All divided by 2a. Okay, so we'll simplify that, and that's our answer, and I don't think it comes out nice. That's why we put it factoring. So
How did you get the 2000
that's b squared. 50 times 50. Okay, so what's 4 times 300?
1200.
And what's 2500 minus 1200? 1300. And the square root of 1300 is not a nice number. So we get 50 plus or minus square root of 1300 over 2. Now what are we solving for? We're solving for x. And I'm going to write it as a decimal just so I can show you how to do that. So if they asked you for a decimal, you just type it in. 50 plus the square root of 1300, and then divide that by 2. So we get 43.03. And don't forget the other answer for x. 50 minus the square root of 1300. I didn't do the minus yet. 50 minus the square root of 1300 and divide by 2. 6.97. Okay, so now we know x, and there's 2 answers. When you're solving a system, what's it very important that you go back and do now? Yeah?
Check your answer.
Well, let's assume those are right. I'm pretty sure those are right. But we've only done half. Well, the amount of work we've done is like 90% of the work, but we really only have half the answers at this point. What do I still need to find?
The y.
I still need to find y. But that's going to be easy because I have a formula right there. Y is just when you take 300 and divide by x. So take each one of my answers and divide 300 by them. All right, so let's do y1. 300 divided by 43.03. 6.97. Anyone have a guess what y2 is going to be? Yeah?
43.03.
Let's take 300 divided by 6.97. 300 divided by 6.97. 43 point, basically 0. It's because of rounding. So this is one answer. This is another. Are those answers the same or different? Yeah,
Different?
they are different. Think about if you were to graph them as coordinates. The first set of points is different than the second set. So those are 2 different answers. So that's solving a system using a quadratic equation. Not everyone works out to be a quadratic, but this one did. Okay, you may have one like that on the test. Any questions on that? If you apply this back to the rectangle problem, that means the answer to that one, you could have a length of 43.3 and a width of 6.97, or a length of 6.97 and a width of 43. It's kind of weird to say it that way, but it basically means this. You could have a rectangle that looks like that as the answer, or it looks like that. It's the same rectangle. It's just one time it's like vertical, and the other time it's horizontal. But technically it is two different answers. Okay. Any questions on that? All right, let's try another one with substitution. All right, which equation here is the easiest one you think to get a variable by itself? You can technically do it with either one, but I think one of them is easier. Sarah?
The top.
I would go with the top one. And which variable do you want to get by itself in the top, x or y? Yeah. If you have a variable that has a 1 in front of it, that's the best one to use. So, using this top one, what does y equal? Yeah.
Y equals negative 2x plus 5.
Yeah, you could write 5 minus 2x, or you could write negative 2x plus 5. That's the same thing. So y equals negative 2x plus 5. Now, once you get x, you're going to fill it in right here, and you'll know y. Okay, but we have to find x first. What am I going to do with the negative 2x plus 5? Matt?
Plug it in the second equation.
For what letter?
For y.
Yep. I'm going to take that. We're going to fill it in right there.
Does it always need to be the second equation, or the opposite one that you didn't use?
It has to be the opposite one of the one you already used, whichever that one is. Yep. Okay, so we've got 3x plus, now be careful because there's a number in front of that y. You need to do it like this. Why did I put parentheses? What property is coming up here? Yep.
The distributive property.
Wait, that's a distributive property. If you don't put it in parentheses, it's not right. You have to distribute this out and now solve it. So, Tyler, when I distribute that, can you tell me what I get?
Negative 6x.
What's 2 times negative 2?
Oh. That would be negative 4x.
So we have a negative 4x plus 10. Okay, combine your like terms, 3x and negative 4x. Zach, what's that going to give me when I combine them?
Negative x.
Yep, negative x. Okay, Jake, next step.
Subtract.
All right, so that gives me negative x equals how much?
Negative.
So negative x equals negative 8. What's positive x? David? 8. Okay. Now, what's the last thing I have to find? Chris?
Plug 8 more into equations.
Yeah, I would just plug it right back into this one. So now take 8 and fill that in right there. And that will tell you why. If I plug in 8 for x, now what's negative 2 times 8?
-16.
So we're going to get negative 16 plus 5, which is negative 11. So you can either write your answer, if it was set up on Inelastic, it's two separate boxes, x and y, or you can write your answer as a coordinate, 8, comma, negative 11. So if we solve this for y and type that in y1, and we solve the bottom one for y and put that in y2, what would happen at 8, comma, negative 11? Yep.
The points would intersect.
That's where the two graphs would intersect. That's where they would cross. We're not focusing on solving systems graphing today, but if we've done a lot of that in the past, that's what would happen. Okay, questions on that? All right, so that's substitution. Substitution, it's fine, it works well. Sometimes it's faster on two variable systems. Very rarely is substitution easy to do on like 3 or 4 variable. Elimination is usually the way you want to go. So the idea with elimination is you've got two equations and you're trying to get variables to cancel out. And the way you do that is you can multiply an equation by a number so that it has a number that's the opposite of a number in your second equation. That's the goal, to try to get coefficients that are opposites. You can either make it so your x variables have the opposite numbers or the y variables, but you want them to be opposite so they cancel out. So you have to get the coefficients of one of your variables to be opposites. To do that, sometimes you have to multiply one equation through by a constant. Sometimes you have to do both equations. What we don't really want to get into is multiplying an equation by a fraction. It's not that you can't do it, but then things start to get messy. So we're going to avoid multiplying through by a fraction. So what numbers could you use? Try to use numbers that are integers. No fractions, no decimals. So we'll start out with a 2 variable, but then we're going to go to a 3 variable. So it's really important we understand the 2, because the 3 doesn't get a lot harder, it gets a lot longer. Okay? It gets a lot longer because it's just more of the same kind of steps repeated. Okay, so here's a nice 2 variable. All right, so first thing we have to decide. Well, the first thing you should do is write it so your x's are in a column, your y's, and the constants. If it's not arranged like that, make it like that first. Okay, so this one's all set. Now we want to decide, do we want to try to make the x's the same, or do we want to try to make the y, I'm sorry, opposite, not the same. Do we want to make the x's opposite, or do we want to make the y's opposite? We can pick either one. Yep.
X's.
Yeah, I like the x's only because one of them is already negative and one of them is already positive. So they already have that going. They already have opposite signs. So what could we multiply the top equation by? And we're going to multiply everything by this number. And I'll give you a hint. Think of the least common multiple between 2 and 3. Get that number in your head. Think of how you can make this that number. Yep.
3.
Yeah, multiply the top by 3. And what are we going to multiply the bottom by? Yep.
2.
2. So the whole goal here was to make the x's 6 and negative 6. Okay. Find the least common multiple, and that's your goal. Okay, let's multiply the top one by 3. Ethan, can you tell me what I get when I triple everything in the top?
6x plus 9y equals 15.
Alright, so there's the top. And Matt, how about when I double everything in the bottom?
Negative 6x plus 10y is equal to 42.
Okay. Now, you don't do substitution. You add your like terms. What's 6x plus negative 6x? 0. That cancels out. So that's the whole goal. You made the x's disappear. Now you only have one variable left. What's 9y plus 10y?
19y.
So we get 19y. And 15 plus 42 is how much?
57.
57. And my last step to get y by itself? Yeah.
Divide both sides by 19.
Yeah. Divide both sides by 19. And that does come out nice. What do we get for y? Yeah? 3. Yeah. Y equals 3. Now we have to go back and find x. Which equation do you think is simpler to use? You can use either one. But should we plug y back into the top or into the bottom? And I'm going to use the ones before I tripled and doubled. I'm going to go back to the originals. Yeah.
Top.
Yeah, I think the top one, the numbers are a little bit smaller. So let's take y and plug it into the top equation. So I'm going to end up with 2x plus, Casey, what am I going to have right after that? So I'm plugging y into the top equation. So you're going to take this equation, right? And what did you just figure out y is? 3. So fill that into the equation I just put a box around. Yeah, 2x plus how much? 9. So 2x plus 9 equals 5. And now solve for x. So we're going to minus the 9. So 2x equals negative 4. Which means x is, yep,
Negative 2.
negative 2. Okay, so there's a problem where we used elimination to solve a two-variable system rather than substitution. Any question on that? All right. So I want to think about, we're not going to do anything graphically, but I want to think graphically for a second. If you graph two lines, and you think about how they cross or don't cross, there's really three situations that can happen. If you draw the two lines, what's one way they could look if you just draw two random lines? Yeah?
Be parallel.
They could be parallel. And if you draw two lines that are parallel, where do they cross?
They don't.
They don't. So that would be an example of a system that has no solution. So you can have a no solution system. What else could happen if you draw two lines, besides being parallel? Matt?
Intersecting lines?
Yeah, they could intersect. Can you be more specific?
Two lines that meet at one point.
Okay, meet at one point. So they could look like that. And that would be an example of a one solution. That's like what we've been doing. That's the last problem. They crossed at one point. What else could happen? There's one more case, yeah?
They're perpendicular.
So that would be like a special case of still crossing at one point. But that would still be one point. Anyone else? Yep, sorry.
Cross at more than 1 point.
Okay, how would that look if the lines cross at more than 1 point? Chris?
The lines could be in the exact same spot.
They could be the exact same line. So if this was your first line and this was your second line, then they're the same line. That's an infinite amount of solutions. One solution, infinite, no solution. That's the three things that can happen when you're solving a system. Actually, they're in that order. One, no, they're not. One, infinite, and none. One, infinite, and none. Infinite's kind of hard to show. So let's try a problem and keep those in mind. We've already done this case. The last problem was a one solution problem. Let's try one of these other ones. Okay, so this is another one that really you want to do with elimination. And this time, I don't think you're going to have to multiply both equations, just one of them. Does anyone think they know which equation we want to change? Daily? Yep, want to change the top one. And anyone else know what we're going to do to change it? Yeah, Jack?
Multiply by 3.
Yeah, it's multiplied by 3. So at the bottom, I'm going to copy it over. Negative 6x plus 9y equals 10. And if I triple the top, I'm going to get 6x minus 9y equals 15. Add them up. What's 6x plus negative 6x? 0. That's gone. What's negative 9y plus 9y? 0. So this whole left-hand side is gone, and you end up with 0. When all your letters disappear, that's a hint we got a special case going on. So we got 0 equals 25. What does that mean? Yep.
No solution.
That's no solution. That's a false statement. 0 is not equal to 25. That means if you were to draw these two lines, they are parallel. They have the same slope, but different y-intercepts. So they never cross. That's a no solution problem. All right, let's try this. This time I'll tell you you're only going to multiply the top by something. Anybody tell me what you're going to multiply the top by? Chris?
2.
2. And what do you get if you do that, Chris?
2x minus 6y equals negative 4.
So 2x minus 6y equals negative 4. And in the bottom, negative 2x plus 6y equals 4. What happens when you add your x's? 0. When you add your y's?
0.
And when you add the constants?
0.
So you get 0 equals 0. All your variables are gone. This means it's a special case. But this is different than the last one. What do you think 0 equals 0 means? Yep.
There are infinite solutions.
Infinite. These are the exact same line. if you were to draw them, they're the same thing. This is an infinite amount of solutions. I wouldn't focus a lot on the special cases. Most of the time they're going to be the one solution case, but you could end up with a no solution or infinite. Okay, questions on that? All right, so last thing. 3 variable. Well, 3 variable is just like 2 variable, except it's more. Quite a bit more. And if you go to 4 variable, then it's a ton more. All right, it's like a tremendous amount of steps. So 3 variable is as high as we go. Here's the general idea. You're going to have 3 equations. You're going to pick one variable to eliminate in 2 of the equations. And by doing that, you're going to turn your 3 variable problem into a 2 variable problem. And then from there, you can solve it, just like we've been doing other problems. So pick a variable to eliminate in 2 of the equations. Okay, so yeah, after you do that, then take those 2 equations and do elimination again. Now you're going to be down to a single variable problem. So you do elimination once, it gets you down to 2. You do it again, it gets you down to 1. And once you get one of your variables, then you work backwards to get the other ones. You use substitution, working back. Right, so we'll try an example. All right, let's try this one. Now, let me give you a hint here that might be very important for tomorrow. Pretend you had a problem where you were trying to find 3 numbers, like we are here, and I said to you something like, if you take twice the first number and add 3 times the second, and then minus the third number, it comes out to -1. If I said that sentence to you, that's exactly how you would write it as an equation. Pretending x is the first number, y is the second, and z is the third. Twice the first number, plus 3 times the second, minus the third, equals -1. And if I said to you, here's another fact about my numbers. If you triple the first number, and subtract double the second number and add double the third number, you'll get 15. This is how you would write down what I just said. And then if you're solving for 3 variables, I got to give you one more fact about my numbers. I could say if you take the first number and add 4 times the second number and then subtract 3 times the third number, you get -8. If you wrote down those 3 statements that I said as equations, that's what it would look like. That's kind of important to know how to do.
So is that how the problem's going to be worked tomorrow? You're going to have it like a word problem?
Yeah, you'd have sentences. Yep.
Okay.
So you'd have a sentence, like this first one would be, it would say 2, I'm not going to write these all out because it's going to take a while. 2 times the first plus 3 times the second minus the third is -1. That's what that sentence means as an equation. And I might write the word plus right here instead of the plus symbol. So taking it from an equation or a sentence and making an equation, that part's pretty easy. It's solving. That's the part that takes much longer. You should be able to write the equations maybe in, I would say, 5 to 10 seconds per sentence. You just read the sentence and write the equation. All right, so let's try solving. So what we want to do is pick two equations and pick a variable to eliminate in both of those. What I generally do, if I can, is I try to look for an equation that has a coefficient that has a 1. Just because a 1 is easy to work with. Okay. So let's try to use, let's call this equation 1, 2, and 3. Let's use equations 2 and 3, and let's get rid of x. Let's try to do that. Let's use equations 2 and 3, and we'll try to get rid of the x. All right, so we've got 3x equations 2 and 3. 3x minus 2y plus 2z equals 15. And x plus 4y minus 3z equals negative 8. What could I multiply this bottom equation by to make my x's cancel out? Yep.
-3.
Negative 3. Okay, so let's do that. Keep the top the same. 3x minus 2y plus 2z equals 15. And now multiply everything in the bottom by negative 3. Negative 3x minus 12y plus 24z equals, oh, whoops, that was the wrong one, sorry. 24 is on the right, that is 9z. Double check it. Negative 3x minus 12y plus 9z equals 24. Yep. Hey, add them up. What happens to the x's when we add them up? Cancel out. What do we get when we add negative 2 and negative 12?
Negative 14.
Yep. So we have negative 14y. 2 plus 9 gives me 11z. And 15 plus 24. 39. Okay, just to make it a little simple to talk about, I'm going to call that one equation 4. How many variables are in that equation? 2. You need one more equation with a y and a z in it to be able to solve. So the first time we did it, we used equations 2 and 3, and we got rid of x. So we've got to get rid of x one more time. But we can't use 2 and 3. We have to use 2 other ones. What 2 other ones could I use? Yeah?
1 and 2.
We're going to use 1 and 2. Okay, we're going to come back. We need equation 4, but not yet. I'll come back to it. So now, let's do 1 and 2. 2x, 3y minus z. What is it? 2x, 3y minus z equals negative 1. And 3x minus 2y, no, whoops. You said 1 and 3, right, Chris?
I said 1 and 2.
The problem to get rid of x there, it's going to be a mess. We're going to have, let's do 1 and 3 just because I like having a 1 right there. So let's do 1 and 3. So 1 is fine. Let's put 3 there. 1x plus 4y minus 3z. And now the goal is to get another equation with just a y and a z that I can use with number 4. And then it'll be just like a problem we've done before. We'll only have 2 variables and we'll solve. What would I have to multiply this bottom one by to make the x disappear? Yep.
-2.
-2. Okay, well, let's do that. Copy the top. Okay, keep it the same. 2x, 3y, minus z equals -1. And Jack, what do you get if you multiply everything by -2?
I got -2x minus 8y
Yep,
plus 6z
yep.
is equal to 16.
Is equal to 6, perfect. Add them up. And whatever we get, I'm going to call this equation 5. What happens when you add the x's?
You cancel.
They're gone. How about when you add the y's?
-5y.
Add the z's?
5z.
Add the constants? 15. Now, there's actually something you could do here to make that equation even simpler. Does anyone see what you could divide everything by? This doesn't always happen. Like if this came out to a 16, you wouldn't be able to do this. But because they're all, well, yeah.
You can divide everything by 5.
Yeah, we can divide everything by 5 just to make the numbers smaller, just like when you're solving a quadratic. -y plus z equals 3. So this is equation 5. And what we had right here was equation 4. Now, forget about the original problem. Solve this problem. This is like what we've been doing. 2 variables, 2 equations. That will get you y and z. So now we're going to work with equations 4 and 5. I'm going to copy them again because I can't see it. -14y plus 11z and -y plus z equals 3. Okay. So let's pick a letter to get rid of. What letter do you want to get rid of there? Yep.
Y.
Okay, we can get rid of y. What would we have to multiply the bottom equation by to make that work? Yep. -14. And now, once we do this, we should have z, and then it's pretty easy from here. Okay, top stays the same. You don't have to keep copying it over like I do, that's just how I do it. Plus 11z equals 39. And Tyler, if you multiply the bottom by -14, what do you get?
14y plus
14y, okay?
minus 14z.
Minus 14z, okay?
Minus 42.
Okay, add them up. What happens when you add your y's? Chris?
Cancel out.
On. Add your z's. Yeah.
-3z.
And add your constants. What's 39 plus -42? Yeah.
-3.
-3. So z has to equal how much? 1. So there's our first answer. Now, I think the easiest thing would be to plug that back in right here and get your second answer. So now the answers are going to come very quickly. Okay, very, very quick. -y plus 1 equals 3. -y equals 2. So then what's y? Yeah,
-2.
-2. Perfect. Here's your second answer. Now the third one. Well, pick one of these original problems that we started with. Let's just do the first one. 2x plus 3 times y plus 3. We know y is -2. Minus z equals -1. So minus z equals -1. What's 3 times -2? Yeah.
-6.
-6. Let's see. -6 minus 1.
-7.
7. And when you add 7 to the other side, what do you get? 6. Which means x equals 3. So once we started solving for the answers, you can see there wasn't that much work left when we got to that point. Getting to that point does take a few steps. It's not hard steps, but it's a lot of steps. But that's how you solve a 3-variable system with elimination. Okay, so homework is 1 through 19, just odds. It's about 10, maybe 9 or 10 questions. Okay, don't forget, we have our test tomorrow. Unless you are planning on being here Friday, you're welcome to use tomorrow as a review day. Talk to me, practice problems, and then take the test on Friday.